Okay, we're going to give it a try here, the video for the Unit 7 test practice. Here's our first proof. I just changed each of these expressions into sine or cosine. 1 over cosine for secant, and cosine squared over cosine for that one. That's so I could get both of those to be combined into a single fraction with a common denominator. And I got sine times sine, so that's sine squared over there, sine squared on the right side here, and 1 minus cosine squared equals sine squared, so I got the same thing. We're done. That's a good proof right there. Next one, quite a bit simpler. If I just cross multiply these two expressions, I get cosine squared equals 1 minus sine squared when I multiply those. Cosine squared equals cosine squared. We're done. That was a pretty short proof. Next one, a little bit longer though, just because I'm expanding it out. There's the angle addition formula for cosine, expanded out with pi over 2 plus theta, and cosine of pi over 2 is 0, sine of pi over 2 is 1, so I got basically 0 minus sine theta, which equals negative sine theta. So we're done with that one. Next one, I multiplied both sides by secant, so I got tangent theta equals secant times sine over here on the right side. Secant is 1 over cosine, so 1 over cosine times sine is sine over cosine. Tangent is sine over cosine, so we're done. For these two angles here in number 2, I chose 315 minus 60 degrees. You could find other combinations from angles off the unit circle to give you that, but when you put those into that angle subtraction formula this time for cosine, it expands out to this, and this is your final answer there. You'll get that same answer if you do it correctly for any pair of angles that add or subtract to 255 degrees. Okie dokie, next problem. Let z be an acute angle in a right triangle, and the cosecant of z equals root 5 over 2. Use this information to find all that stuff. Here's the picture of the triangle. If the cosecant of this angle is hypotenuse over opposite, that's what cosecant is the reciprocal of sine, then I would label the triangles like this, and that third side is 1. So this gives me the sine of z is 2 over root 5, cosine is 1 over root 5, and the tangent is just 2 over 1, or just 2. And so then I'm just using that in all these different double angle formulas. For sine, I get 4/5. For cosine, I get negative 3/5. And for tangent, I get negative 4/3. So here's my explanation, a long-winded explanation as usual, why we use the plus 2 pi thing. So let me back off so you can see all of this. You can stop the video if you want to read that, if you can read it. I don't want to read it out loud. Anyway, there you go. The next problem. Let's see, determine the exact value of this hairy looking thing. So I expanded both of those expressions out to give me all of that stuff. So sine, cosine pi over thirds, that's 1/2. Cosine times sine pi over thirds, that's root 3 over 2. There again is root 3 over 2 for cosine, and sine of that's 1/2. And what happens is I got negative 1/2 times sine, positive 1/2 times sine, so they cancel out. I've got negative root 3 over 2 times cosine, and positive. All the terms cancel out. This expression equals 0. Okay, solving these equations here. Set to 0, so I set each factor equal to 0. And I've got then from this tangent equation here, x equals 0 or pi. I'm just expressing that as pi times k. 0 plus pi times k. So that's one way to write that. I get pi over 6, 5 pi over 6 and 7 pi over 6 for the cosine equaling negative root 3 over 2. So that's these two angles here, and so I express that this way with the plus 2 pi k to show all possible solutions. And part B. Let's see, I isolate the trig expression here to get cosine of 3x equals positive root 2 over 2. That means 3x equals pi over 4, because that's the cosine of something equals root 2 over 2. That's at pi over 4, and it's 7 pi over 4. So taking these two little expressions here and dividing them each by 3 to get my solutions. X equals pi over 12 plus 2 pi k over 3, or 7 pi over 12 plus 2 pi k over 3. Okay, so at the end, the period of this function is 2 pi thirds, and we add the period times k to our solutions from the unit circle, or whatever we get. Okay, here's the other one where I had to use a calculator. This one's tricky, folks. So the sine, when you isolate that out, equals negative 2/3. Well, I want an angle that's not negative. I want an angle that is positive. So my calculator tells me that the inverse sine of negative 2/3 is negative 0.73. To get that, what I did was I added 2 pi to get an angle that's between 0 and 2 pi. This is a negative number. I want a positive number between 0 and 2 pi. So that I got this. Now, my other trick, however, I'm going to use that negative angle when I subtract. Pi minus negative 0.73 gives me positive 3.87. The reason I didn't use this one and subtract pi minus that is because that would give me another negative angle to deal with. So my two angles between 0 and 2 pi are this 3.87 radians and 5.55 radians plus 2 pi k. That was a tricky one. You may have to stop and think about that one for a second. The next one, there we go. Cosine squared equal minus 4 equals 0. So I set that equal to 4. That means that the sine squared is the reciprocal of 4, which is 1/4. When I take the square root of 1/4, I get plus or minus 1/2. So the sine of m equals plus or minus 1/2. That's 4 different angles. These two are for positive 1/2, and the next two are for negative 1/2. So it's this whole set of 4 different solutions to that, plus 2 pi k. All right, once again, the period of that is 2 pi, so that's why we add plus 2 pi k to show all possible solutions. And then here we got these tricky inverse trig expressions. Sine, so I used a right triangle here. The inverse tangent of 12 over 5 might be this angle right here, which the hypotenuse then is 13, so the sine of that is 12 over 13. All right, next one. I used a different triangle. The inverse cosine of that, showing 3 over 5. That means our sine is 4 over 5. But this is an angle here that has a cosine of negative 3/5. So this is the sine of 2 times that angle. It's a double angle formula for sine. So 2 times the sine times the cosine. And that gives me negative 24 over 25. Part C. Tangent of this thing right here. Well, inverse sine of 1 is pi over 2. Inverse cosine of root 3 over 2 is pi over 6. Pi over 2 minus pi over 6 is pi over 3. So I'm taking the tangent of pi over 3, which just equals square root of 3. Next one. Sine, okay, so this is an angle again with having a tangent of root 2 over 3, so that might look like this, which gives me a hypotenuse of square root of 11. You can check that with the Pythagorean theorem. And so the sine of that is just opposite over hypotenuse, which I rationalize the denominator to give me this expression right here. Next one, inverse cosine of sine of pi over 6, that's 1/2. Inverse cosine of pi over 6 is pi over 3. Tangent inverse of this thing right here. This is not double angle because this isn't an angle. This is the cosine of an angle, which is a number. All right, that number is negative 1/2. 2 times negative 1/2 is negative 1. So I'm just taking the inverse tangent of negative 1, which is negative pi over 4. Keep it in our range right here of inverse tangent. Remember, is negative pi over 2 to pi over 2. So that number has to be in that range. All right, shoot, this should say negative 1 right there. So here's the ranges. Make sure you get all of those. That's a fact. You got to know these things. It helps with all of these inverse trig expressions. We made it. Okay, thanks. Bye.